حضورنا الكريم، السلام عليكم ورحمة الله وبركاته. نرحب بكم مرة أخرى في المؤتمر الدولي الثاني عشر وينكوم، المقام في هذا الصرح الذي أسسه الأمير الراحل طلال بن عبد العزيز آل سعود رحمه الله، استكمالا لجلساتنا الحوارية. فلنرحب سويا بضيوفنا الأستاذ الدكتور باسكال لورينز من جامعة أوت ألزاس في فرنسا، ومن المغرب جامعة محمد الخامس بالرباط الأستاذ الدكتور عبد اللطيف قبان، فليتفضلوا مشكورين.
Assalamu alaikum. Good morning, everybody. Before introducing our keynote speaker, I would like to sincerely thank the Arab Open University for their hospitality and excellent organization. Now it's to introduce our keynote speaker, Professor Pascal Lorenz, who will talk about architecture of next generation network. Professor Lorenz is a renowned researcher from the University of Haute. He has authored over 200 international and 3 books and 3 patents, and his research focus on quality of service, wireless network, and high-speed working. He has held several leadership roles within IEEE Communication Society, including technical editor of IEEE Communication magazine, chair of IEEE ComSoc France, and distinguished lecture, and he has also contributed to IEEE conference such as IEEE ICC, Globecom, WCNC, and PTC. And please join me in welcoming Professor Pascal Lorenz. The floor is yours.
Thank you for the introduction. I will present a large presentation. I will present quality of service. For quality of service, you have different parameters. For example, what is important is bandwidth. You need a lot. For voice or IP, you can see it's not bandwidth because if you give a call, if only 10 kilobytes is enough, then latency. Then we can see, depending on the application, not all parameters are important. Bandwidth, latency, jitter, packet noise, packet delay, and so on. We can classify the quality of service with different. You can see ETSI define, for example, 4 class. Class 1, best effort is. Class 4 is QoS guarantee. You have a very good quality, but of course it's more expensive. We have also quality of experience is a sub quality. We can see internet continue to grow more than 5 billion. Provide, we increase every year, the bandwidth increase, and you have not a lot of new technology which are. We can see development in the last year of CTI merging together the last year, and we see development last year of and mobile telephony. We can see also evolution. We have less and less cable. and we'll see in the next slide development in the future. We have seen also in the last year, we have laptop is only data, cell phone only for voice, and today with smart. Maybe tomorrow we have one unique device with a laptop, with development of laser keyboard, of holographic OLED screens. There is different new technology which will next year. We have seen also development of WDM. Today it's possible to have more than it's possible to have more than 1,000 different color of laser on the same optic. You can have a blue laser, green laser, a yellow laser, and so on. Then the bandwidth by you can use different type of color of laser. We see also development of optical switching. Here 5 millimeter, and you can have full optical switching. It's not necessary to go from optical, electronic, and return to optical. You continue to be full optical. We have seen the last year also development of in a lot of countries of optical fiber. Initially it was. Now it's we have FTTH everywhere, and of course also you have possibility to have FTTT directly. For the class of service, that is different. Quality. VBR, you reduce the quality. ABR, you give only a rate, and UBR, no, it's the best effort. No quality. But it's cheap. We have in the past also development switching IP. We have a router and a switch. First packet arrive to find the route with the router, and all other packets are only. With this one, with this approach, you avoid the router bottleneck problem. Router is very slow, and you can have congestion with the router, and then this technology has been developed by TLS, multi-protocol label switching. Then to give quality, you have we'll see different. You can have MPLS, multi-protocol label switching. Fast forwarding that to avoid router bottleneck problem. You can have another approach is in-serve. If you want quality, you reserve. Then you are sure to have very good quality, but the reserve bandwidth you have not. Body then is a good solution, but it's expensive solution because you have not scheduled. Is not scalable, then you have because the amount of states increase proportionally. Then it's a good solution, but only for small networks. Another approach for the quality is diff-serve. Then you share the bandwidth, and you have a hierarchy. It's not all new packet we are removed, but only the packet with a lower. For example. You remove the packet. If you download a movie, you can remove this packet because you wait 5 minutes. You can add wait additional time. It's not a problem if you destroy this packet because RTCP will retransmit later. But you do not remove the packet voice over IP because voice over IP is only 10 kilobytes, very small packet, and then is real-time traffic. Then you should not remove this. Then you can differentiate the traffic. Then you can have different approach. And today the approach is provider is diff-serve over MPLS. Then we will focus now more in see that there is more and more wireless communication, and we will see that there is a lot of technology. every 10 years we have passed a new generation. For example, in the year 80, we have 1G. 10 years later, 90, 2G. 3G 2000, 4G 2010, 5G 2020, and 6G will be developed with 6G will offer a tactile internet, a massive low massive scalability, massive security, and it will be a good solution, especially for vehicular edge computing. And there is a lot of other solutions, about satellite communication and all these different type of quality and security problem resolved with this solution. For example, for quality of service for wireless network, we have a specific problem for wireless device. For example, battery is a problem because you have certain energy. Then maybe tomorrow we can see maybe some approach on hydrogen battery, superconductor. That is for the future. We have different solutions to communicate, and we will file data and approach. First approach is focus on the radio electrical. It's a good solution, large distance, penetrate. Infrared is no more used. In the past, laptop with infrared today is no more used because it's small distance and do not. Microwave is a distance up to 80 kilometers. Today we see a lot of development with LiFi, VLC, visible light communication, with a LiDAR, a lot of the connected, the possibility to have a LiDAR. And especially is a good solution for vehicular networks. Use this technology, and LiFi today is possible. It's an old solution, but not very developed. You can transmit the internet through the fluctuation of the light, and then you avoid to some constraint of the wave. For the different approach, 1 to 5G, 1G is based on technology, it's FDMA, frequency division. Then you can see quickly it's not a good solution because we have not enough frequency. 2G, the approach is TDMA, time division multiplexes, and you have the time. If there's too many people, of course, you have not large bandwidth. 3G, code division multiplexes, and it's better, but you have every station device can communicate at the same time. Code, and you increase the bandwidth. With 5G, 4G, we have introduced. Then you increase the bandwidth because you have more frequency. And 5G SCMA, for example, FOFDM, MIMO, NOMA, non-orthogonal multiple access, and a new technology will increase. We will present in the next slide and the bandwidth. Satellite. Yesterday we present 3 different approach: low Earth orbit, medium, and geostationary. We can see that the frequency is more and more higher. Initially 40 gigahertz, 50 gigahertz, because we increase the bandwidth, of course. And LEO is yesterday we 50 satellite can cover the world, and that is the first picture of the first. Today is, of course, different. We have not this necessary to have this picture. Initially, in the past, we have Iridium. After Global Star, we have one. We see a lot of big development in the last months of SpaceX. which represent 6% of internet with and also Amazon with Creeper. But yesterday we have presented data in this approach. MEO is more higher altitude, 5,000 to 20 kilometer. Delay is more important. And the 12 satellite can cover the world, and you can find GPS approach or Galileo, which is a European GPS solution. GEO is more higher, is 36,600 kilometer. This altitude is important because the satellites go to the earth that is always at the same direction. You have and we can see antenna, but it's not a good solution for telephony because you need and it's complicated, of course. To communicate with mobile phone is better low Earth orbit, of course. Then it's good solution for TV if you have on TV reception only, or other approach of. Yesterday we presented also. Then Proteus picture of presented yesterday. Here you have Google Known project, and here another approach with a drone. We can be used for antenna. During the day you refuel the battery, and it can be used as an access point, just 20 kilometer. For telephony we have different size of cells. Either the cells have femto pico cell up to 50 meters, and the access point is your box at home. If there is less people, you can go 10 kilometers with size between 50 to 500 meters. GSM quickly was the first after appear different we can see 5G, 3G, and is, for example, in Europe it's more GSM. Initially we have not one unique standard in the we can see quickly in the past we have a 2.5G with a G 48 kilobytes. It's very small. After appears the 150 kilobytes, still slow. After appears the 3G with IMT2K, international mobile telecommunication, and then the standard was UMTS, universal mobile, with a 3GPP, third generation partner project approach. And then we see with 3G the speed is only 384 kilobytes. It's still slow, but quickly appears a 3.5G or with a standard with a HSDPA, high packet access, a rate of 4 megabytes. It's beginning to be a good solution. And after 3.75G with HSUPA, high speed up rate up to 6 megabytes. After we have development of 4G with a rate of 300 megabytes. 5G appear with a gigabyte approach, and after tomorrow probably we will have a terabyte communication tomorrow with low latency and so on. It will be good solution for especially virtual reality, extended reality. We need large bandwidth communication solution. IoT, Internet of Things, there is a lot of device for need of Internet of Things, because we can see between 2010 2020 we go for 5, continue to increase. We have more and more device connected, and people want to have large high data rate, low latency, high low device energy consumption, and low device. People want affordable and sustainable solution for communication for Internet of Things. And then different approach we will see quickly. For example, between 4G and 5G, we see development of slice. We have, for example, possibility to have a slice for vehicular, one slice for Internet of another slice for vehicular, another slice for voice over IP, and then also another massive. You can have massive reliability, and also development is the latency, because for 4G we have only 50 milliseconds. It's not. And then with 1 millisecond, with 5G, better solution than it can. Other solution which cannot be used for if you use only 4G. So and also lower cost, and we will see use of with 5G millimeter wave technology, with use of massive MIMO, and the possibility to have a private 5G. And there is, of course, overlaid over 4G solution. And it uses also new band as well as for Internet of Things. Then we have a lot of different solutions. Box, for example, and for computing, which is a cloud for Internet of Things. An approach with cloud with security, and we will see that with a lot of different solutions we take up. It can be used for example, light switch, traffic light, parking meter. All these devices are connected. We have seen also development of new with a separation of data and control plane, with a new development of MEC. MEC is a mobile edge. We can see different size of data center. You can have the cloud, you can have the MEC, and if you reduce, you have the fog computing, and skin the mist of the femto data center with possibility to have a virtual Wi-Fi, virtual controller, and so on. And then different solution, also different product. We can see different software also on app. Internet of Things, we can see a combination of massive MIMO, advanced cloud radio access networks, and then the solution can be used for this Internet of Things. 5G is not the only solution. .11EH and different type of approach. But today we can see a lot of network for Internet of Things are based on 5G narrowband 802.11EH, but other solutions are possible also. Quickly about IEEE 802.15 for wireless personal area networks. Then you find solutions such as ID, ZigBee, ultra wideband, NFC. For the IEEE 802.11 local area network, solution since 19 is Wi-Fi, which represents about 7% of traffic today, and wireless metropolitan area networks, and 802.22 with wireless regional area network. And we can see there is not one single technology that can satisfy all technology and solution. Quickly about wireless personal area network is for then the distance is very small, about a few meters, and then And you can, everybody knows solutions such as Bluetooth, but there is wireless USB, ultra wideband, UWB, and for example for toys you can have a Zigbee approach with a low complexity, low and very cheap for toys. Of course, the standard is IEEE 802.15.4, and the speed also is very slow, only 2000 kilobytes, but for toys is enough. And you can see that is approach for personal area network, small distance. If you increase the size of distance, you enter in the world of local area networks. And then you can see in the past the different standard Wi-Fi 1 until today Wi-Fi 8. Wi-Fi 1 you can see 11A. Wi-Fi 2 is 11B with a rate of only very slow, 11 megabyte is very slow. 11G is Wi-Fi 3 with a rate of only Wi-Fi 4 with 11N, then the rate is 300 megabyte, still low. After appear Wi-Fi 5 with 11AC, and then you can see development approach with offer possibility to have a beamforming, and then the rate is 500 megabyte. Wi-Fi 6 today with 11EX, and the rate is up to 11 gigabyte. You have Wi-Fi 6 and 6E, two different approach in terms of gigabyte. Today we have also possibility to have Wi-Fi 7. A lot of device, computer are E, and then the rate up to 30 gigabytes. Of course, Wi-Fi 8 with a rate up to and then you can see if you are very close, if the device, you should have a few meters. If you have more, if two different floor, then it's not possible to have high-speed communication, so type terabyte Wi-Fi 8 tomorrow. And then if you have distance are more higher, then you can see solution, for example, for 11F, you can have up to a few kilometers, but a few kilobytes. Then depending on the distance, large distance, you have only a few kilobytes. Short distance, you have gigabyte, terabyte tomorrow. The solution based on wireless metropolitan area network, WMEN. Initially we have WiMAX, but today is no more used because a lot of companies buy frequency, but today people prefer to use solutions such as 5G, 4G, and then it's no more used today. Quickly, we have other approach of wireless regional area networks, regional distance, 100 kilometer, and then we can see different approach with also 21, which is devoted for an off among different type of network and different networks. Then we can see the evolution in the past. Initially, GPRS was based on frame relay, UMTS on ETM, and today all is full based actual solution on IP. Then today an efficient support of internet is not possible with a core which is totally based on IP protocol. What about tomorrow? Next generation network, we will see all type of communication. There was still some problem today. We will next slide is a problem of consumption of energy. We know that they consume a lot of energy, and it's a problem. For example, TCP consume a lot of energy. Will be a problem tomorrow. We'll see development of intelligence in internet. We see a big development in the last year of a solution based on SDN, on NFV, network function virtualization. We have more and more virtualization today of NDN, named data networking, of big data. Data is important, and development of Internet of behavior. We have approach of software initially we have more hardware approach. We see more and more a software approach, which is a network. We perform any kind of mission based on the cloud networking and geographically distributed data center to support smart network provision, self-orchestration, network automation, and so on. We see as it's like a Uberization of the network. We can see with a big development of GAFAM, we have we see also development of different type of slice, vertical slice, which is possible with 5G networks. What about tomorrow? Tomorrow we are probably be convergence with 5G and the Wi-Fi. Have probably the self-characteristic development of very low Earth orbit. We see with the approach proposed by Starlink, by Amazon also with Kuiper. Maybe if it is very cheap, maybe people will prefer to use satellite communications and national provider, depending on the price, of course. We see introduction more and more of artificial intelligence, machine learning in the networks. One problem which for tomorrow is consumption of energy. Energy is a very big problem for tomorrow and for a lot of country, because we can see digital technology consume more than 10% of world electricity, and server alone consume 4% of world electricity. And for example, 80% of data in transit in the provider is only video. Then we can see the video consume a lot of energy today. It was as much as was emitted by the world truck fleet, or twice of the emission of air transport. We can see the prime of energy for digital technology tomorrow. And for the traffic, we can see if we divide between network and horizontal vertical. And for example, for vertical network, 40% of the traffic is for satellite, and in this 40%, 6% is only for Starlinks. We have a position is a market today in satellite communication. 40% telecom provider, and 40% GAFAM is Google, Amazon, Facebook, Apple, Microsoft. Big 5 owner of networks. About horizontal traffic, we have 8% is private, 60% Wi-Fi, and 30% is device-to-device communication with the development of Internet of Edge. Also, we see tomorrow we will have more and more development with satellite and things, because we can, if you buy the new smartphone, you can see is your chip for communication to satellite is integrated. Then we can see satellite will be represent a big part of communication, probably. Cable, also optical cable. We can see the GAFAM are the owner of a lot of cable in the world, and we see the evolution between 4G and monolithic approach to a 5G more. It's a more microservice approach, and 6G approach with the hot topic today and tomorrow, of course, it will be security and energy conservation. That is, I think, the two hot topics for tomorrow. And we are going for an approach for virtualization with the development of, we have generative, behavioral, adaptive, artificial intelligence. Then we are going for a network approach, more to a digital infrastructure approach for tomorrow. Okay, we have time for questions.
Thank you very much, Professor. I have two questions. The first one, how do you envision the balance between the hardware acceleration and emerging technology, such especially cloud architecture is there? This is the...
Yeah, with this approach, we can see initially we are going more today with some solution is a hardware virtualization, development of FPGA with a field programmed gate array with specialized chip which are able to reduce energy consumption. We know that energy is a problem and software consumer. Specialized chip maybe tomorrow would be a good solution to the more hardware approach with a low energy consumption with a generation of we will reduce this problem of energy.
Yeah, exactly. The second question, how can highly automated and orchestrated architecture to maintain strong security and guarantees, particularly in environment slice such as vehicular, drone, IoT, network, and carrier-grade services?
Yeah, we see the evolution. We have different good devices with Internet of Things, and then for all this type of network, we have seen that in the slide that some networks we have development is the last year of software-defined networks of a different approach for communication, and all solutions give different quality, and depending different quality, different price, and then it's important to define, if you create a new network, what is the best solution depending of you different. And then we have, it's a reason we have not one unique network, different type of network, because there is different needs of communication and different need of quality and constraint in terms of some network are real-time constraint or not real-time constraint. We have this different type of approach today.
Okay, thank you. Any question for audience? Mike, please.
Hello, thank you for nice conference. Exactly about this slide. Is there any hope that at some point we can newer architecture?
Yeah, there is, of course, there will be an evolution. Beginning, we are in the evolution today. Continue the evolution. Is we can see evolution of next generation. Focus on. As I presented in the last slide, it will be more focused on development of, we can see introduction of, very important is the next generation. We have more and more utilization of artificial intelligence. Solve some problems such as and development of new, we will see probably development of new infrastructure. It's difficult to know what will be the future. an approach based on serverless approach because because we know virtualization there is of energy and the new approach should be developed tomorrow to solve this type of problem for next generation of internet.
Thank you. Just the last question. Which big players do you think are to test the new technologies? For example, now if someone has some suggestion like recursive network, TCP/IP and legacy systems, do you think, for example, big players like Google would be interested to make changes into their existing?
Yeah, the GAFAM are access point to, if you want, there are leader in a lot of committee suggest some solution. Of course, we can see the approach of the GAFAM and low Earth orbit approach. We can see there is some commercial aspect and there is new technical approach, and of course the leader and the GAFAM are very important for future internet tomorrow. Of course, it's importance of this provider to.
Thank you.
Okay.
Actually, I have two questions related to each other. The first question, with you're looking for future, when do you think we will apply the IP around the network?
Good question. IPv6 has been created more than 20 years ago. I hear 20. The problem is money, because for your laptop it's easy, but the problem is the core of the network. There's a lot of router, switch are not easily upgraded, and a lot of technology are very old, and you should replace. But who will pay for this technology? And we have find a lot of solutions, a lot of patch today to continue to use IPv4. Then public, private address, and so on. Then different solutions. Then I think that we'll need one day will appear a killer application and appear. Then we have no choice. We have no choice. We should go to IPv6, and if not, we cannot use this new application which will be created tomorrow, which will be this. But I don't know exactly the date when we will.
But how many years do you think it will take to converting to IP6? If the governments start to make it like one of the rules?
I think it's a problem of money, because the problem is only money for IP. Technology is ready, and
that's good.
If the money is here, we can change quickly.
I believe the problem is with the software. The other question I want to ask, could we have an IP for a PAN network? I think for something like the Apple Find network, how they converting the Bluetooth mesh network into something like public. What do you think?
About Bluetooth and, sorry?
Sorry, I mean the Apple Find network, it's converting the Bluetooth network into something public, so you can find your device wherever it is in the world with the Apple devices. So could we have IP for PAN network?
Yeah, there is different solution, of course, but Bluetooth is we have a classification. I presented a classification of different. I will show you the slides of different networks, and depending of the size of possibility to have different size of solution, and of course you can have a gateway between you can see whereas personal network, LAN networks, only the size of the network, you have very small network, large networks, and then of course we can see all these solutions communicate together, but we can see the quality is different. We have not the needs in a personal network, small network, different solution and different constraint and different protocol which are different of your constraints.
Okay.
Thank you, Mr. Pascal.
Last question.
Thank you for your talk. Actually, till now there is a lot of machine learning AI solutions for internet, increasing the internet speed and routing and everything. But when these solutions will be applicable in the devices itself, I mean when the AI will be hardware, existing hardware.
Yeah, it's difficult to know the exact. This solution will be integrated, but we can see there is more and more development and development, especially by the GAFAM provider, and integrated a lot artificial intelligence in a lot of networks. We see big development of software-defined networks, of name data networking, of and we can see introduction of software which is more and more important in the networks, and of course artificial intelligence is networks, and it will be I think increase big development is a future. It will be big development will be I think increasing more and more with the use acceleration of development with this utilization of this technology.
Okay, thank you. Also, what about the free space optics? I think the free space optic technology will increase internet speed as much as possible, but still it's under research or under investigation.
Yeah, we see for optical communication, we see development of WDM. Today it's very expensive to put one new optical fiber, but for Europe today is more cheaper. You have you add a color of laser and you bandwidth. Of course, the problem is to when at the any color which are very close, it will be very separate the different type of color. Then today we can see in lab we have more than 1,000 different color, but tomorrow there is no limit of color because there is million. Technology is not. We should increase the technology to separate the different close color at the reception, and but it will be possible tomorrow. But there is still research aspect.
Thank you very much, Professor. Thank you for your patience. Okay, thank you very much.
وأما الآن حضورنا الكريم مع جلسة عمل خاصة بعنوان حلول هواوي لشبكات عالية الجودة في مؤسسات التعليم العالي، مع المهندس عمر حياة مدير تكنولوجيا حلول الشبكات، فليتفضل مشكورا.
Assalamu alaikum. Good afternoon, everybody. My name is Umar Hayat. I am the Senior Solution Architect and CTO for IP Networks. you just had a very wonderful presentation talking. Today I will be talking about solutions from. I'm sorry. Yeah, you can hear me. Yeah. So I will be talking about IP solutions, particularly Wi-Fi solutions. And you know, nowadays the hot topic is Wi-Fi 7. So I will show you what Huawei has brought to campus solution focused on Wi-Fi 7. Agenda is very simple, that Huawei, who we are, where we stand in the market. I'll be talking about Wi-Fi solutions and multi-gig switches to cater about the efficiency of those solutions. And then something about Huawei SD-WAN and Huawei security portfolio in very brief. Who we are. Huawei, we are the largest ICT provider in the market. Although we are running 4 different businesses, like for the carrier, where we are providing 5G services. Second is the enterprise networks, where we do all the data center solutions, SD-WAN, security, routing, all those things. Third one is the consumer business, where we have the business for the mobile devices and laptops. And the last one, which we have recently introduced and started in Saudi, is the cloud services. Now today we have our own cloud node in Saudi, and we can provide all those cloud services also. Globally, we are more than 200 for Huawei, where 50% of those employees are working in R&D. We are present in 170 countries, and the salient feature is that we spend more than 20% of our back into the R&D to bring the innovative solutions in the market, right? The last thing you see, we have 140,000 plus patents registered with the organization. So this shows that how much we are spending and what innovative solutions we are to the market. And I will show you some solutions, those are unique and nobody else is offering in the market. Wi-Fi 7, which is a topic for me. We have the largest contribution for defining the standards for Wi-Fi 7. Although our contribution across the Wi-Fi, starting from A2.11, ABG, and AC, AX, Wi-Fi 7, but especially for Wi-Fi 7, you can see in the, we have the largest contribution in the market. That was the reason that we brought Wi-Fi 7 access points in the market before anybody else. Why? Because the guy, Edward from Huawei, he was the technical editor for ratifying the standards for Wi-Fi 7. So we knew what is coming in the market, so we introduced like 2 years back. And now we have the broadest portfolio for Wi-Fi 7, where some of the other vendors are still introducing the Wi-Fi. It's a marketing slide. It's just a Gartner report. It is published every year, and they evaluate different vendors for different categories like data center or campus solution, Wi-Fi, security, all those things. So for the last consecutive 3 years, Huawei is in the leader quadrant. What brings us in the leader quadrant, by the way, Huawei is the only non-American or non-European vendor who is sitting in the leader quadrant. For the last decade, it was dominated by Western vendors. So with this investment in the R&D and new standard introduced by Huawei, we have been able to come in the leader quadrant. And if on the right side you see the statement from the Gartner, who has mentioned the strength about Huawei. What is that? One thing, they particularly mentioned that Huawei has the strongest and broadest portfolio for IP networks in the market. Second thing, what they mention is about our management platform. We have a unique integrated management platform that not only manages the devices, rather we manages the users also. And in the devices, whether it is a router, it is a switch, it is access point, anything on the network we can manage. On top of that, even the user management is also done through the same management platform, through a NAC solution. Maybe you have know about that, network admission control, where you control the users who have the access to. Access is denied, or even if you are authorized, what kind of authorizations you have, where you can go, what kind of servers you can, which websites you can go, what kind of bandwidth you should get. All those things are controlled through the NAC solution within our management platform. And that management platform is AI based. Some of the networks are like autonomous driven. So there are pre-configured algorithms in the platform that can monitor and analyze the network 24/7. So it's just like a technician is sitting there 24/7 monitoring the networks, and if there is any problem happening, it can not only detect that problem, it can take the remedial action to fix it. So that is also a strength mentioned by Gartner for our management platform. The third one, the last one, is the product innovation. As I mentioned, that we are bringing innovative. Huawei is bringing real innovative solutions. One example is that in our Wi-Fi solutions, we have some of the features incorporated in it which are supposed to be coming in Wi-Fi 8. I will talk about that in the later slides. This is our Wi-Fi 7 portfolio today. You can see that we can address any size of the network for the enterprise. You see on the top, those are the flagship access points. In the middle, medium level, low level, outdoor access points, and there are some special access points. Those are focused for the industry institutions, like in the hospitals, in the hotels, hospitality business, where mostly, you know, Wi-Fi is networks is unpredictable. If you have a concrete walls and you install the Wi-Fi access point, on the other side of the wall, maybe you will not get the signals here, right? So the penetration of the signal is difficult in the concrete wall, and especially if there are metal rods. For those kind of solutions, we have small access, and they can provide the connectivity inside the room. Very small. And if you talk about the large auditoriums like this, or the stadiums, where thousands of people will be connecting to, we have the highest capacity access point 8771, which can give a throughput of 18 gigabit per second. Aggregated bandwidth 18 gig. How it is possible? It is using the 3 radios. As I see in the previous slide, there is Wi-Fi 1, 2, 3, 4, 5, 6, 7, starting by 802.11b, which was only 11 megabit per second. Then next Wi-Fi 2 was introduced, 802.11b, G and N. It was giving you only 54 megabit per second. Okay, and those were using the frequency bands what? 2.4 and 5 gigahertz. And again, when we introduced Wi-Fi 4, 802.11, the maximum bandwidth available to any station was less than 1 gig, 900 something. In Wi-Fi 7, we can go beyond 3 gigabit per user. Okay, although Wi-Fi network is a shared media. It is not like a switch that you have 24 port, 1 gig switch, and every person connected to the port will get that dedicated bandwidth. No. Wi-Fi, when you increase the number of users connected to the access points, bandwidth will be divided. Okay? Although there are some techniques like the special stream support, there can have multiple users transmitting and receiving the data there, but still it is a shared media, right? Now one question arises that if we have that high bandwidth on the access point like 18 gig, 13 gig, how you do the backhaul connection? Because earlier in up to Wi-Fi 6 or Wi-Fi 5, the access points were connected to the switch on 1 gigabit Ethernet cable. Now if we use that cable, although that will work, but that 1 gigabit cable to the access point will be a bottleneck for the users. In the air you have 18 gig, and on the back side if you connect it 1 gig, it will be bottleneck. So here the new switches were introduced, multi-gig switches. Those switches can provide you 1 gig, 2.5 gig, up to 10 gig connectivity. So you don't have a bottleneck for the Wi-Fi networks when you connect to high performance access points. And by the way, other than that, we have some unique solution to cater this problem. I will show you that solution in the coming. One thing about the protocols, that what is the major difference between these Wi-Fi 5? As you can see in the first line, Wi-Fi 6, they use only 2 frequency bands, 2.4 and 5 gigahertz. And the modulation was 1024 QAM. There was multi-resource unit, but not like Wi-Fi 7. And the last thing was what? Multi-link operation, MLO. In this one, this is a particular thing you should remember for Wi-Fi 7 and the other standards coming in the future. Up to Wi-Fi 6 and 6, the user can connect to the access point on only one link, on only one radio. If your device is operating on 2.4 gigahertz, you will be able to connect to 2.4 gigahertz radio on that. If you have 5 gigahertz, which will give you better bandwidth, you will be able to connect to 5 gigahertz band or radio on the access point. So you have only 2 frequencies, okay? And you can use only one at a time, okay? In Wi-Fi 6E, which came for a short time, although there was a new frequency band introduced, 6 gigahertz, but still, you see the bandwidth available there was only 9.6 gig aggregated on the access point. Because I will show you in the next what was the difference. But the major bandwidth, the highest bandwidth available, and the operation was not multi-link. Okay. Now in Wi-Fi 7, although we have 3 bands like Wi-Fi E, but here the major difference is, you see the last corner, multi-link operation. Wi-Fi 7 enables the users to connect to the access point on multiple radios. Could be 2.4 plus 5, 5 plus 6, or 5 and 6, to get you a very high bandwidth on the device. Aggregated bandwidth, theoretically it is 23 gig, but normally in the access point till now we have up to 18 gigabit per second available on the access point. So this is the major difference. Although there are some differences, like we can have a frequency channel of 320 megahertz, which is double than the Wi-Fi 6E and Wi-Fi 6. We have modulation instead of 1K up to 4K. And then we have multi-user RU per user. This is again a very unique thing in Wi-Fi 7. Up to Wi-Fi 6, what was the division of the time for the users? That if 10 users are connected, the access point will divide the time for 10 users. 1 second, 1 second, 1 second, 1 second. Let's say, just example. So during that 1 second, only that user will be communicating to the access point, whether it has a data to send. So that 1 second will be wasted if there is no use of that. So here in Wi-Fi 7, so the multi-RU per user is that if it is my turn and I have no data, I can give it to the next. So it is more efficient scheduling of the users to get maximum performance from the access point. And the last thing, as I mentioned, MLO, multi-link operation, that is the unique feature available in Wi-Fi 7 to make it much more efficient. This is a report from Tolly Group. Tolly Group is an independent entity who do the testing for different network devices and publish the report. So they have tested Huawei access points, the flagship access point, and they have concluded that access point to access point can go up to 13.25 gigabit per second bandwidth. Keeping within the range, depending on the antenna, what kind of antenna is there, you can go up to that bandwidth. And from the access point to a single user, as I mentioned, the access point is a shared media. So if only one user is connected to the access point, that can get up to 4.33 gig throughput in ideal condition. Now there is another myth, and there is another that when you go and try to sell them Wi-Fi 7 access points, they always say that my devices are old, my devices are all Wi-Fi 6 or Wi-Fi 5. What benefit I will get from going to Wi-Fi 7, right? So Wi-Fi 7, because it has different technology protocols, so by using those advanced technology, even if the device is Wi-Fi 6, that will get better benefit when connected to Wi-Fi 7 comparing with Wi-Fi 5 or 6. Okay, so you can see the example that if this device, Wi-Fi 6 device, is connected to, it will get 987 megabit, but the same device when connected to will get the double bandwidth, 1.5 gig. So this should also be clear in the mind that going to Wi-Fi 7 definitely give you benefit, even your devices are not supporting Wi-Fi 7. These are some of the features available and introduced and unique to Huawei Wi-Fi access points. Number one is the antenna type. We have dynamic zoom, intelligent, smart antennas on our access. They can follow the users. And this technology we adopted from our 5G guys. Like in 5G communication, the antenna, you can follow the users. We can do it in our access points. Because our access points, there are 16 element antenna that can be controlled. So that can be controlled by the controller to see where the users are. Example is, like in this kind of hall, if everybody moves to one corner, the access point can detect where are the user, where is the user density. If they are equally distributed, it will work in normal form. But if all the users connected to the access, it can turn off different elements of the antenna and can focus on that direction to give the better performance. Then on the access points, in Huawei access points, we can detect the type of right on the access point. Don't have to take the traffic all the way to the controller and then detect what is going on the network. What benefits you get by this feature? That if you want to stop any application, you want to give priority to the traffic, or you want to throttle it, you want to limit the traffic bandwidth, you can do it right on the access points. So those are the features again available on the. The other thing is the roaming, AI-based roaming. What is that? If you have multiple access points in your campus, and like now everybody has a mobile device, so you are moving, you are connected to the Wi-Fi, but you are moving from one access point to the other access point. In the old days, when the controller was not there, the access points were deployed in autonomous fashion. Each access point has its own configuration. It does not know what is the next access point. So in that case, when you are moving from one access point to the other access, your TCP session will, you have to re-authenticate if you move from one room to the other room, and this signal is not available there. So the user will be disconnected and reconnect to the. But now, when most of the access points controlled by the controller, and we have in Huawei controllers this function AI roaming, that we can detect that what is the routine of this use. So we can cache the credentials to the next access point before it goes there. So there will be seamless roaming, no interruption at all when the user switch from one access point to the other. And the last thing is the AI network optimization. So with the management platform and the coordination with the controller, 24/7 we can optimize the network. Wherever there is a poor coverage, we can do it automatically based on, again, the AI algorithms defined in the controller. So the controller can detect what kind of coverage one giving. It can automatically expand or contract the field to give the best coverage for the Wi-Fi networks. This is the innovative solution from Huawei. Maybe you have never seen this solution from any vendor. We called it hybrid cable. When you connect the access point to the switch on the Ethernet cable, you have a limitation of 100 meters. Sorry for my throat. So if the access point is more than 100 meters away from the switch, it costs you to connect it. Either you have to put another switch in between, or you have to put a fiber and then media converter and then. So to break this 100-meter limitation, Huawei introduced hybrid cable. It is even thinner than category 5 or 6 because it has only 4 elements in it. 1 pair of fiber, 1 pair of copper. So the data will go on the fiber and the PoE power will go on copper pair. So no matter where you are installing the access point, you can go right from 300 meter all the way to 2 kilometers depending on the PoE power. So it is ideal solution for a very large campuses. You don't have to put cabinets on each floor or each 100. No, you make one communication cabinet, one communication room, and run this hybrid cable to 300 meters, 500 meters, 1 kilometer, and this cable will provide the data connectivity and the PoE power to the device. And this device not only is the access point, it could be a switch also. I will show you in the coming slide that we have some of the switches that can also be powered up by this hybrid cable. And then they normally work as a switch. Could be 4-port switch, 8-port switch, 12-port switch. So those are very ideal solutions to minimize the cost and make very efficient network solutions. This is the example of that hybrid cable. That on the left you see it is a traditional one. You put the core switch in one floor, the other floor you will put the distribution switch, third floor, and then you will run the cable to the switches, to the printers, or to the access point. But if you use the hybrid cable, you will have only one communication room. From there, you run the hybrid cable, maybe 10 floor up, 10 floor down, and you can use only one modular switch to do the network for the whole campus. And if you calculate the cost, you can save like 30–40% of the cost by going with this solution. But obviously, this solution is particularly for very large campuses. We are doing a POC, proof of concept, for the mosque, Prophet Mosque in Medina. So they don't have to put the communication cabinet on each. So we will have one communication room, and from there we will bring the hybrid cable, the whole mosque to connect. The Wi-Fi will be provided in the mosque using minimum cables. And also, you know, this hybrid cable, if you see is much lesser, maybe 10 times less than comparing to the copper. So easy installation, more efficient, more bandwidth, and also, you know, it is future proof. Today you can connect 2.5 gig transceiver, 10 gig transceiver, and maybe tomorrow, when more bandwidth is required, you can connect 25 gig transceiver also. And those special transceivers are available. Those will fit on the access point, and because this transceiver has the fiber and copper connectivity on it. Clear? Any questions? I want to make it interactive. If you have questions, you can ask me now also. So these are some of the details about the, like I mentioned, this is the flagship access point, 18.6 gigabit per second throughput, aggregated throughput. How that throughput is achieved, you see the special streams based on the frequency bandwidth, like 4x4 on 2.4 gigahertz, 4x4 on 5 gigahertz, and 4x4 on 6 gigahertz. And on the hardware side, on the Ethernet side, you will have 10 gig ports. So you can connect either two 10 gig copper or one 10 gig copper and one fiber, or one hybrid cable. If you connect, you will have non-blocking thing there. And by the way, you heard about the Bluetooth and other protocols for the network, personal network. So we support Bluetooth on all the access. Zigbee protocol is there. And on top of that, we have some integration for IoT devices also. Like, this is something unique feature from Huawei, that some of the access points have high security features. So in conjunction with our management platform and using a license also for this feature, we can provide a very secure connectivity to the end users. This is not available from any other vendor till now. So only the authenticated user will see that. Otherwise, nobody can detect or hack the access point, because they will not get any clean traffic there. Will be garbage. This is the IoT integration. We have some of the access points, they have the option to put IoT from other vendors directly into the hardware. So we have alliance with so many partners. They have their PCI cards. We can install it in one access points to provide the services like BLE, RFID, Zigbee, like ESL, electronic price labels, asset management, and other energy efficient and barcode reader in the, and there are so many other solutions available, like for the healthcare, you know, for the babies, you put the wrist tag on that, so they will not be mixed up, or you can monitor it from there. So for this integration with IoT, you don't have to, only one Wi-Fi network will provide the Wi-Fi services and the IoT services on top of that, managed by our platform or the platform integrated from that vendor. Very cost effective. The other new technology but introduced by Huawei, the comprehensive mesh. Although the mesh is available from the other vendors also, but the maximum hops available for the mesh is 5. What that means, that you connect one access point to the cable, and then other access points can be connected. So from one access point, you connect one radio to the other, next to the next, and you can take it up to 8 access points with one backhaul connection. So in the middle, the access points are not connected to the cable. So this is another very, for the dry ports or the area where the users are less, but the connectivity is required. So we can provide that also. And this is outdoor with the outdoor antenna. These are the outdoor access points. We have outdoor access with built-in antenna. Built-in antenna mostly, so you just install it in the middle and 360 degrees it will give you the coverage. Or if you are in a stadium, you install it in the wall and you put the directional antenna and you cover that area outdoor. And those outdoor access points are all IP68 rated, means what? You can install it in the outdoor. If it is raining, flashing, whatever, temperature, high temperature, up to 75 degrees Celsius, no problem. Those are designed to be ruggedized. These are the small access points for the hospitals or hotels or the areas like university dormitories. So for the student rooms, instead of putting it outside or in the corridors, you can directly, you can install it there. These are the controllers to control those. So if you see the capacity of the controllers, again, I will say Huawei is leading in the number of access points can be managed through the controller. We can manage up to, here you see 20K, but actually today we can manage 30K, 30,000 access points. Nobody can match that. And small up to just 512 access points. So whatever size of network you have, Huawei, they have the solutions to provide you. This is the portfolio for the switches. You know, for the best Wi-Fi 7 network, you must have a very good infrastructure for the wired network. Because if you have 18 gig available from the access point, you should have efficient network to bring that 18 gig to the core switch or to the distribution switch. So here is our portfolio for the core switches, modular aggregation and access switches. So all kind of, and this like 8700 switch, it is a unique modular core switch from Huawei that can support the hybrid cable, the multi-gig cable, 10, 25, 40, 100 gig connectivity, whatever. Only one switch can provide you the network for the whole campus. Other than that, we have fixed port switches also, and these are the switches like the industrial switches. They can operate in ruggedized environment up to 70 degrees Celsius. You can just put it somewhere where the air conditioning is not available. Those are, and the multi-gig switch, you see 5700 series, 2.5, 5 gig, 10 gig with uplinks of 5 gig, 10 gig and 100 gig. Those are available. Variety of the switches are there just to provide the connectivity to high performance Wi-Fi 7 network. And the last one, I will not go into the detail. Those are the switches to provide you fiber to the office, FTTO. Like you don't need to run the hybrid cable or Ethernet cable. Rather, you can, if you compound for villas, you can run a single fiber everywhere to connect the devices on the end. No need to go for expensive. Because this solution, the passive one, it does not require power even. If you are distributing the connectivity, you put a passive device there which will take the fiber signal and split it into 4, 8 or 12 without power, because it is only the light. No need to have heavy switches to power up and boost it. These are the industrial switches, ruggedized. If you want to do the outdoor coverage for the Wi-Fi 7, you can install these switches outdoor in the cabinet. No need for air conditioning or something, because these can bear the temperature up to 70 degrees Celsius. So even in the extreme heat, they can work. something about the switches. When we talk about the very advanced high performance networks in the campus, obviously you will be of the redundancy also. What if the switch fails, then you have a lot of access points. So in Huawei, we have switches, they support not single power supply or double, up to 3 power supplies. So if one fails, switch is working. If 2 power supplies fail, it is working. And if you have all 3 power supplies in the switches, you can have maximum PoE budget. You can power up a lot of IP phone, lot of access points from that switch. These are the switches. Those can be powered up by hybrid cable. So what if you are installing something, access point, it's only one port required. But if you are bringing this hybrid cable in a conference room where you want to connect the interactive screen and you want to connect the printer, so you can use these RU remote unit switches and connect it through the hybrid cable and get more Ethernet connectivity there. More economical and efficient solutions. This is, by the way, our comprehensive portfolio, what was mentioned by the Gartner. Very broad portfolio. We have separate products for the campus, separate product for the data center, SD-WAN, routers, security, all those. And on top of that, you see the application layer where we are managing all these devices through our management platform, which is called iMaster NCE. If you see what is iMaster NCE, Intelligent Management Center, NCE is Network Cloud Engine, that can provide everything from single platform. SDN controller, you just heard about the software defined networking where you are separating the control plane from forwarding plane. So this SDN controller for Huawei is built in the platform. You don't have to bring a separate box for SDN controller. You talk about the network management, device management, it is there. You talk about the user management, NAC solution is there. SD-WAN, if you want to connect different universities or different branches together on a normal internet line, we can provide it through SD-WAN connectivity. So we have full variety of those routers that can establish the SD-WAN connectivity for the users. And then security management is there, and the network analyzer is also there, which is called Campus Insight, through which, based on the AI algorithms, you can have autonomous driven network. So if there is any problem going to happen, it can detect and it can inform, or if it can fix itself, it will do automatically. Then within the management platform, we have something called digital. So digital map is just like a digital twin that you can create a simulation of the network to see how the network is performing. And it could be on the device level, on the user level, and on the application level. So all those 3 layers, you can have a visual analysis there. So before any problem happens, you can detect and take the remedial action. For a small network, we have this webmaster piece of management built in our switch. You don't have to worry about the servers or other devices to run the management software. Rather, this webmaster is built in all the distribution and core switches. So you don't have to buy the iMaster NC if you don't need it. If you have less than 500 devices on the network, no need to buy a separate management software. You can manage it within the network, within the switches. Regarding our certification, we have 3 levels of certification, especially for the students, that you can go for the associate level certification, professional and expert. Like other vendors, we have also the same thing. Only the good thing about Huawei is what we always provide free trainings to the partners and even to the customers. So there is a published schedule available on our website. You can register and you can attend the online training free of cost. And then afterwards, you can go to the Prometric Center to give the exam, then get the certification, HCIA, HCIP, or HCIE. These 3 different levels of certification. For SD-WAN, as I mentioned, that if you want to connect different branches together, your platform and SDN controller will be the same. But you have to install the routers in each branch and provide a simple internet connectivity. No need to go to the service provider to get a leased line, or rather, using this platform, using SD-WAN controller, you can establish SD-WAN using our routers. And this is the range of the routers you can use for SD-WAN connectivity. The last thing, because I'm running out of the time, is the security. Because this is again the basic requirement for all the networks to provide. So we have full portfolio for the security, from the modular firewalls to, if you go to a very small network, a desktop version of the firewalls also. Very large to very low. Terabit throughput up to few gigabit throughput. So all those kind of things are there. And these are different models of the firewalls. We can protect the network on any borders. Thank you very much. That's all from the presentation. If you have any.
Assalamu alaikum.
Salam.
As one of non-specialists attendee, I found your representation very interesting, but especially that the idea that single access point that you present can support many Internet of Things technologies. Especially they can connect different radio. I have one simple questions. This technology are already be in our reality, or still it will be in the future?
No, it is available. You know, as I mentioned, depending on the alliance. So we have some partners already tested it, because this is a PCI card. So IoT provider, it is not provided by Huawei, but we provide a standard connectivity in our access. For the other vendors to bring their PCI card, it is SIM card, like you can USB to any device. So they can connect that card. Their controller will be that card, but it will be integrated with ours. And we have already done some of the solutions for especially the supermarkets, where they can put the electronic label price tag. So no need to go and write the pricing there. They can, from our Wi-Fi network, they can change the pricing from the management platform, and it will be reflected on the shelves.
And this is also with the single.
That is already available there. We are running this one. Other one for the hospitality, we have some IoT things. Those are used in the hotel rooms. So if for the curtains and other things, they can be there. For hospitals, we have solution for like asset tracking. You know, sometimes if you have a mobile X-ray machine or portable vital signs machine, misplaced sometimes. So they have to run into the rooms where it is. So if you put a tag, asset tracking tag there, you can see that asset in your monitoring station where it is, room number 120. So immediately go there and bring it. So these kind of IoT solutions are already there in production in the customer side.
Other question related by, I think, called Webmaster or?
Yes, Webmaster, yes.
Okay. This is need some technical skills to use it, or anyone can?
For the networks, if you have a basic knowledge of networks, the connectivity, they can run it. No expertise is required. It is all GUI based. That you want to see the topology, you will just log into that one, Webmaster, and click the topology. It will show you how many switches you have, how many access points, how many routers, how they are connected, what. And if there is a problem in the link, if you turn off one device, it will show like this link goes red. So it is very easy to use. No expertise required, just a basic knowledge of that.
Okay, thanks a lot.
You're welcome.
Thank you very much for your presentation. My question about if you have any solution or software, for example, like Cisco, for example, packet tracer, we can simulate all this product.
Yeah, we have very good solution for education. Yani, it is integrated solution, I will say again. That rather, we are providing the interactive screens also, where you can interact with the students electronically. So that their tablets will be connected to our interactive screen. That is not part of my portfolio, but that is there, and those all will be connected to our. Okay.
And we can test. We can test in the
yes,
material.
it is already there. Yeah. We can do that. And then if you want to do the attendance, we have some solutions for the attendance, that when the user come and connect to the Wi-Fi, can do it. Or you want to do the face recognition, something we have Huawei cameras also, AI based cameras, they can do the face recognition also. We can do like the parking solutions, we can, through those cameras, we can read the number plate of the cars. And this is already implemented in Huawei office. So that kind of solutions are available, yes. Yeah, please. Please go ahead.
Thank you very much, Mr. Ramar. It's comprehensive, and I will call it marketing
I'm
presentation.
sorry.
Yeah, but I have like a technical question and a request.
Yeah, please.
The technical question, once I'm having like my mobile,
Right.
just out of the coverage of Wi-Fi, have the what we call the to cellular networks.
Okay.
So in the access point itself, this is what vertical. So as a user, I will be affected. I will notice this different frequencies.
See, different frequencies have their own benefits. I will tell you. If you are using 2. By the way, in the mobiles, normally all the old and having 2 radios, like 2.4, 5, and now 6. Some of them they have 6 also. So mostly 2 radios, not all 3. So the handshaking, when you connect to the access point, they will detect where is the best performance available, high bandwidth. Now how it will make the question here, 2.4 gigahertz, the low frequency can go in more distance. 5 gigahertz will cover short distance. Yeah. So if your mobile has both of them and you are away from the access point where 5 gigahertz cannot give you good coverage, you will automatically be connected on. And this is we experience every day in our homes. You put the router, and in some room you will be connected to 2.4 only, because the 5 gigahertz cannot reach there, because the router or the access point is away from that. But automatically, if the device and the access point has to decide, if there is any problem, seamlessly it will switch to that. Yeah. And if it is Wi-Fi 7 device and it supports MLO, multi-link operation, it will connect to 2 radios and give you much higher bandwidth than Wi-Fi 6 or Wi-Fi 5.
Okay, as a kind request also, this is maybe follow-up for you know, as university, and we want I'm ready for the market. However, for example, in telecommunication or fields, we want like the technology to be built in our.
Right.
For example, Cisco, they are very successful in this. We cannot see Huawei doing this. and if there is a يعني إن شاء الله يعني future plan to see like our labs and our setup that we can train our students on that.
Exactly. I agree with you. We are little behind in that, but we have already some of the agreements with some university. I don't want to. There, the Huawei Academy is there. They have Huawei. But I think we already have a discussion on that. I don't know. Mustafa is there. So we are ready to do that. And if you want to cooperate and have some, why not? We are very much into that. Yes.
Okay, thank you.
Hello, thank you very much for the. One question about the innovation. Is there any that, for example, call for proposals that people can just or know each other to conduct some proposal or?
Yeah, for the innovations, we have innovations. Till now, it is not there in Saudi, but we have in the Middle East, we have in Europe, we have in China, we have not in America.
Right.
We are not allowed to do business there, but in Mexico, we have it there. But on the other hand, if you want to see something, we have a POC lab in our office where you are welcome to visit, and we can show you the things in action. Like the IoT question was there, whether it is exists or it is future. No, we have a lot of scenarios which we can present to the customers and partners, and if you want to see, it is there.
Yeah.
But for the innovation lab, or if the students want to contribute,
Yeah.
our management to look for that.
Thank you. I'm just thinking about Huawei. That if, for example, they have called for a proposal and found that for example, researchers from all over the world, they can just send a proposal or just Huawei devices and so on to test their own research.
Right. Yeah. Point taken. I will discuss it.
Thank you.
Good question. Thank you very much. Thank you very much for your attention and nice questions.
يتقدم سعادة الدكتور بندر الرامي لتكريم المهندس مدير تكنولوجيا حلول الشبكات، فليتفضل. وفي ختام هذه نؤكد أن ما طرح بالأمس واليوم من أفكار ورؤى تعكس عمق الخبرة والتنوع المعرفي لدى المتحدثين والمشاركين، ونأمل أن تسهم هذه المناقشات الثرية في دعم مسيرة التطوير والابتكار وفتح آفاق جديدة للتعاون والعمل المشترك. شكرا لكم جميعا على حضوركم ومشاركتكم الفعالة. نتطلع إلى لقاءات قادمة أكثر إثراء وتأثيرا. ينتقل المايك إلى الأستاذ فيصل غامدي.
السلام عليكم. تفضلوا معنا على المسرح لالتقاء